Hey everyone, welcome back to Soft Spoken Scientist. Today we're simplifying square roots, also known as radicals. These show up in the quadratic formula, distance formula, geometry, and tons of algebra problems. So learning how to break them down the right way is super important. We're going to take it slow, keep it calm, and I'll show you exactly how to simplify square roots, even when the numbers get a little messy. So, when you simplify a square root, the goal is to break the number into factors, where one of them is a perfect square. Perfect squares are numbers like 4, 9, 16, 25, 36, 46, 64, 81, 100, etc. Now, when you take the square root of each of them, okay, you're going to get 2, 3, 4, 5, 6, 7, 8. Square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, square root of 144 is 12. I think you guys got the idea here when you take the square root. But a square root is not the perfect square. These numbers are the perfect square. The ones that up here with the stars is labeled perfect square, okay? The ones below, those are the results of when you took the square root of those perfect squares. So you have the square root of AB, it's just A times B. So you have the square root of like, if I told you guys the square root of 25, right? You guys would know that's 5. All right. So, yeah, going back to that. So if you can rewrite your number as a perfect square times something else, you can simplify it. Let's do some together. So I said simplify, and I gave you guys the square root of 75. If you watch my last video, you'll know a little something about this. So you have to ask yourself, what times what multiplies to get you 75? I know that would be 25 and 3, because you don't want to do 75 times 1. That wouldn't get us anywhere. You don't want to do the same number in the square root times 1. So I have 25, and I'm going to say, okay, what times what multiplies to 25? Well, 5 times 5 does, right? Okay. If you have the same number, like 6, 6, even the 6 is here, 1 6 is here, it doesn't matter. If you have the same number twice, they're going to team up and become 1, and then they're going to go outside the house, also known as outside the square root. So you have 2 5s, so that's just a 5 outside the square root. 3 is lonely, has no one else to buddy up with, it's by itself. It doesn't have another 3 to buddy up with, so 5 square root of 3. That's your answer. Next one. Square root of 49, if you look back at the perfect squares, would be 7, because 7 squared is 49. Square root of 25 is 5. If you look back, you'll know 5 squared is 25. Square root of, yeah. And then square root of 36 is 6. 6 squared is 36. All right. Now we have the square root of 200, okay? What times what will get me to 200, you guys? I know 2 times 100 would. And I know 100 is a big number that could be, that is formed because of 10 times 10. And what times what gives you 10? 2 times 5. 2 times 5. So, I'm going to use purple, okay? You got a 2 here, and you got a 2 here. You got a 5 here, and a 5 here. So, they become 1, you got a 5. These 2 2's become 1, you got a 2. What's 2 times 5? 10. So 10's going to go outside the square root. She had 5 times 2 outside the square root, because they buddied up and went outside together. They have their friends. This little guy, this 2, is all by itself, because they can only go out in groups of 2. So this 2 is going to remain inside the square root. By itself, at home, by itself, okay? So this was your answer. I know they like to overcomplicate it, but it's not that bad. The square root of 121, if you look back at it, you'll know that it's 11, and that's something you guys should look back and review, I'll scribble up here, the perfect squares. And it makes sense. 2 squared 4, 3 squared 9, 4 squared 16, and etc. Okay. Now we're dealing with 4, we're being told on exam, like simplify, 4 square root of 27, right? What times what gets me 27? I know 3 times 9 does. And I know that 3 times 3 gets you 9. So I'm going to take these 3. These 2 are going to become 1, and they're going to leave and go outside the square root together. Sorry about that message. So you're going to have 4, and then you have this 3. Because remember, they become 1, and they go outside. This 3 is all by itself, so it's going to stay indoors by itself. What's 4 times 3? 12. Bingo. That's it, you guys, on that. Now, this one's a bit trickier. We have the square root of 45 times x to the third power. Let's start with the number. We got what times what gets me 45? I know 9 times 5 does. And then I know 3 times 3 gets me 9, right? Okay, great. They are buddies. They can go outside and hang out, right? Outside the square root. So you have 3, and then inside you have a, let me put a little space. You have a 3, and then you have a 5. Now you have x cubed, okay? That is formed from x squared and an x. And you may be saying, well, how did you know that? Well, good question. So when we're multiplying those two exponents, remember, it's raised to the invisible 1. They don't write it, but it is. So you keep the base the same. What's 2 plus 1? Because you got to add your exponents. 3. Okay? So these are still under a square root. Just how, like, these were under a square root, you know? I just don't want you guys to get confused. I don't always write it in. So here's the deal. You have to ask yourself, the square root of x squared would be what? And that would be x. So that's going to go outside. All right? This x has no one to go outside with, as this one is already broken down to a perfect number. And this is an exponent, so it's a little bit different. Because it was broken down, and that's another thing you guys should know. That's another rule. You have like x squared, it can be broken down to x, and it's outside the square root. X cannot be broken down to anything. Square root of x can't be broken down to anything. So that's just going to be inside. So your answer is 3x with the square root of 5x. That is your answer. Last but not least, we're dealing with the square root of 72, x to the 6, square root of 72, x to the 4th, y to the 3rd. I'm going to break 72 down into, well, what multiplies into 72? 36 and 2, right? There you go. 6 times 6 gets me 36, and I know 6 could be broken down into 3 and a 2, 3 and a 2. So look at this. They're friends, and they're going to go outside the square root. Okay? These two 3s are friends, and they're going to go outside the square root. So you got a 3, and then you got a 2. 3 times 2 is 6, and then you got this 6 out here. That's all outside the square root. So it's 36. You got 36 outside the square root. So I'm going to write 36 with the square root, but I need to add some space for the other exponent, for the other letters. Okay. So I got the square root of x to the 4th. Okay. Square root of x to the 4th is x squared. And the reason I know that is because square root of 4 is 2, square root of 9 is 3. Okay, so it was like x to the 9th. It would be x to the 3rd. So this is an automatic perfect square, so we can just go hang out outside. You can go outside, square root. Now you have y to the 3rd again, under a square root. Let's break it down. Y squared, and then y. Square root of y squared is y. Great, it's a perfect square, it can go outside. Now you got this y all by itself. It never got broken down, so it has to stay inside. So what that would do for me is say, okay, and then real quick, you see this 2 out here? It had nobody, so it still has to stay inside the square root. And then this y wasn't broken down because it was just already there. This is your answer. Great job today. Simplifying radicals might look intimidating at first, but once you learn how to break numbers and variables into perfect square factors, everything becomes so much easier. If this lesson helped you, please like and subscribe so I can keep making clear, calm math videos for you guys. And always remember, STEM is for everybody, especially you.